Hey everybody, Mr. Troy here. I got a quick video for you on sequences. We are starting a new unit called linear and nonlinear functions. Let's do this. It's time for math with Mr. Troy. I hope you're dancing along. All right, folks, this video should help you with the next 3 lessons in Algebra 1. We are going to be studying sequences and series, and we're going to start with arithmetic sequences. Now, you pronounce this arithmetic, not arithmetic, even though it's spelled the same way. An arithmetic sequence is a progression of numbers where each number is separated from the previous number by the same amount. So this is an arithmetic sequence because each set of numbers, or each pair of numbers, is separated by the same amount. That amount, whatever that amount is called the common difference. So we would say this is an arithmetic sequence because the common difference is 4. If you wanted to tell someone everything they needed to know about this sequence, you could say that its common difference is 4 and that it starts with 3. That would tell them everything they need to know about this sequence. So each item in an arithmetic sequence is called a term. And we are going to start with the first term, the second term, the third term, the fourth term, etc. You know something is an arithmetic sequence if it has a common difference. So for example, for this one, each new number is subtracting 6 from the one that precedes it. So to extend this sequence, we would just subtract 6 again and get negative 29. And we could go on as long as we needed to, just by subtracting 6 every time. This dot dot dot, or as you would call it in English class, an ellipsis, is just a way of saying that this pattern continues on in this same way. So for some things it can be really simple. 1, 1.1, 1.2, 1.3, 1.4, 1.5, etc. I think you could probably guess what the 5th, 8th, 9th term of this sequence is, except you have to remember that this is the first term and that this is the second term and this is the third term. So if I asked you for the 9th term, it would actually be 1.8, not 1.9. That's something you've got to pay careful attention to. This arithmetic sequence has a common difference of 0, so every number in it is 5. We're adding 0, we're adding 0, 5, 5, 5, so on and so forth until the end of the universe. There are 2 different ways we talk about formulas for arithmetic sequences. One is called an explicit formula. That formula tells you a certain term in the sequence. So for example, this formula could be used to find the 5th term or the 7th term or whatever. The n is what you are going to replace with the term number you want. So if you want to find the 5th term, you need to plug in 5 and then just do the arithmetic to figure out what that is. Now, if you were to plug in 1 and then 2 and then 3 and then 4 and then 5, you would get this sequence. So what you notice here is that this gives you the first term, and this gives you the common difference. This is very similar to a slope and y-intercept. But a slope and a y-intercept need you to have x and y, and this doesn't have this. This is just a list of numbers. So you can't call this the slope. You have to call it the common difference. and you can't call that the y-intercept. You have to call it the first term or the initial term, okay? But very, very similar to how you would plug something into a linear function. So just a summary, remember that an explicit formula will find you one term in a sequence if you know what number it is. So what's the 50th term or what's the 700th term? The second type of formula is called a recursive formula. A recursive formula is one that will give you the next term in the sequence if you know a particular term. So if you know the 7th term, it'll tell you the 8th term. If you know the 20th term, it will tell you the 21st term. Okay? There are two parts to a recursive formula. Some of you will have seen this in middle school, but not everyone talks about this. So the two parts are the first term. So this is saying, whoa! This is saying that the first term is 5. Now, the next part is the key. The next part is saying if you want to find the nth term, you would take the nth minus 1 term and add 3. So this is going to be a, that's not how you spell that, a next term part of your formula. So this n minus 1 just means the one before a particular one. So if you want to find a term, take the previous one and add 3. So this is our first term, and this 3 part is our common difference. So start at 5, add 3, add 3, add 3, add 3. I could define this same formula, but instead of saying a of 1 equals 5, if I could say a of 3 equals 11, then that wouldn't be the first term, it would be the third term. But it would still tell me the same things. Now, how would you work your way backwards? Well, if adding is how you go forwards, then subtracting is how you go backwards. If I've been adding 3, adding 3, adding 3, if I needed to go backwards to the first term, I would subtract 3, subtract 3. Now, you do stop at the first term. You don't go to the 0th term and the -1 term and whatever. You don't do that. Okay, hope that was helpful. See ya.